Hello, everyone. Hello, Doctor. Today I will present our research paper is containerization and virtual machines security and efficiency trade-offs. Our group is me, Mohammed ABDULRAB, and Yosuf AL-Hataef with Ahmed Al-Mossad. Our research paper contain the abstract and introduction, uh, architectural foundation, and isolation mechanism with the graphs and security. So I will explain and present the first part in our presentation here. Then we will continue to other paper here. So our presentation will start with containerization as virtual machines, security and efficiency trade-offs. So the first part here is the abstract. The trade-offs is this paper present a comprehensive analysis of containerization, various virtualization technologies. We examine the critical balance between security and efficiency and performance in modern deployment. While containers, Docker, and Kubernetes offer superior resource utilization, they introduce significant security complexity and due to shared kernel architecture. So the key findings here is virtual machine provide robust hardware level resolution, but incur high overhead. So in contrast, containers priorities agility. The study evaluates hybrid approach like gvisor and Kata containers and provides a recommendation based on current industry trends, which show 84% corporate adoption. So introduction, evaluation of infrastructure. The computing landscape has shifted from heavy hardware level isolation to lightweight operating system level virtualization to meet the demand of rebate scaling. So in 1097 century, virtual machines emergency of hardware level and virtualization of efficient mainframe utilization. And in 2000 century, Linux containerized introduction of name space and C groups, prioritizing and performance over isolation. Docker and KBS here, key, key 8 is a standardization of containers lead to massive industry adoption and new security risk. Between 2013 and 2014, and architectural foundation, virtual machines, hardware level isolation. Virtual machines execute a complete just operating system independent of the host operating system. This, as shown here in this photo, the hypervisor acts as intermediary ring one relevant hypervisor like KVM operate at the highest privilege level, creating a strong boundary. Heavyweight, each VMware requires its own kernel and memory allocation. It's 128 to 512 megabyte. And security guarantees exploiting VMware requires and breaking out of the hypervisor, which is rare. So the point number 2 is architectural foundation containers. Operating system level isolation containers share the host kernel. They are essentially isolated process using Linux parameters and namespace provide isolation view of the system BID networks mount and C group limit resource use like CPU and memory and shared kernel risk as a single kernel vulnerability affects all containers on the host. the third point is comparative isolation models. We have VMware isolation and container isolation. Hardware enforced the boundary is physical. Hardware emulation and threat model attacker must escape the hypervisor and verdict robust, secure by default, but resources intensive. Container isolation software enforced the boundary is logical, not physical. A namespace, a threat model attacker must escape the kernel, and verdict efficient, agile, but likely isolation model. So this part, security analysis and container vulnerabilities is on my friend Yusuf. He will start now after me.
Now we are in the third point, which is security analysis, the container vulnerabilities. The shared kernel architecture express the large attack surfaces. Recent critical, the SVA stands for the several exponent demonstrated this desk. As we can see, those are three phases. We do have the RunC vulnerability and the kernel heap overflow. And we also have the file extension, which is cgrow escape. Now we move to the next point, which is hypervisor security profile, and so the main benefit of this is to reduce attack surface. Hypervisor have a significantly smaller code footprint compared to the monolithic Linux kernel, which is around roughly 40 million plus, could be more line of code. And the simplicity. Now we're talking about the simplicity. Hypervisors performs fewer tasks, CPU scheduling, memory mapping, everything leading to fewer bugs. And also catastrophic but rare. Vulnerabilities like VENOM CV 2015 345 are devastating but occur far less frequently than container escapes. Last point is the mature technology that decades of hardened the enterprise environment. Now let's move to the next point, which is privilege escalation techniques. So as we can see here, 3 points out of them as the phases. We do have the kernel exploitation, which is exploiting bugs in the shared kernel. For example, dirty cow to gain root on the host. And we do have the misconfiguration. And this is running for containers as privileged or mounting sensitive host paths. It can be whatever path it needs to be here. And also we do have the eBPF oppose, which is a malicious programs like bypassing safety checks to read and write kernel memory. It's not only for read, it's read and write kernel memory. Now as we can see in the chart here, for the efficiency analysis, the resources consumptions, we do have containers. So virtual machine memory, as we can see here, has the overheaded, more than the container memory and VM pod, container pod. Now the destiny and CPU efficiency. So this picture illustrate for us and make everything, many things clear, which is 20 for the virtual machines per host. That's limited by memory and CPU overhead, and it can. So this one is not constant. It depends on the machine that it's been used for the virtual machine. So that is versus the containers per host. Containers per host, it gets 500 and plus. It could be more than that, and that's near native performance. So the container in core is from 0 to 5%. CPU overhead is from 5 to 20% for virtual machines due to the trap and emulate operation.
Hello, my name is Ahmed. I'm gonna handle the last part of this presentation. On this slide, I'm introducing a GFISor, which is a Google's user space sandboxing technology. The idea behind GFISor is to add an extra security layer between the container and the host. Instead of letting the container directly interact with the host kernel, GFISor intercepts system calls and sends them through a user space kernel called the sentry. This reduces the attack surface because even if a container is compromised, it can be directly reach the host kernel. There is a small trade-off. This extra filtering adds about 10 to 15% performance overhead, but in turn it's great for running Antrust or third-party code and for multi-tenant SaaS platforms where strong isolation really matters. And next on this slide, we have Kata containers. Unlike GFISor, which runs in user space, Kata provides isolation using lightweight virtual machines. Each container runs inside its own micro virtual machine. This gives us the best of the both worlds, the security of virtual machine, but with the speed and packaging convenience of the containers. Because each container has its own detected kernel, it greatly reduces the risk of kernel level attacks spreading across the workloads. Kata also integrates smoothly with Kubernetes through runtime class, so teams can selectively choose strong isolation where needed. And on this slide, it shows that's happening in the industry today. First, 48% of organizations use Kubernetes, showing that containers have become the standard way to deploy modern application. Second, about 18% are using hybrid security models such as GFISor or Kata containers, especially in regulated environment where isolation and compliance are important. And lastly, traditional virtual machines are declining. Pure virtual machines use age has developed to around 15%, and they are mostly used for legacy systems or working loads that require very heavy isolation. On this slide, we compare virtual machines, containers, and hybrid solutions like Kata containers and GFISor. Virtual machines offer strong hardware level isolations, but they are slow to boot and have a low resource efficiency. Containers are the opposite. They start very fast and highly efficient. Hybrid solutions stay in the middle. They provide strong isolation than containers while keeping the boot time and efficiency at responsible level. On the slide, first, confidential computing. This uses hardware features like AMD, CSV, and Intel TDX to encrypt memory even while applications are running. This means data stays protected even from the cloud provider itself. The second technology is EBF security. EBPF allowed small programs to run safely inside the kernel without adding a new kernel modules. Next, on the conclusion, complete isolation always comes with a cost. The more isolation you want, the more you sacrifice efficiency. Thank you for your attention.